Let's look at another problem for Hess's law. And again, remember, this is about manipulation of thermochemical equations. So you take 2 or 3 equations and then you get to your final equation. So here is the equation that's given to us. So carbon monoxide gas and nitrogen monoxide gas gives us carbon dioxide and half of nitrogen. So we are asked to calculate delta H for this. And again, 2 equations are given to us. All right, and the 2 equations are carbon monoxide plus half oxygen to give carbon dioxide, which delta H is minus 283, and then another one, N2 plus O2 to give 2NO. Okay, and delta H is given also for that. So equation number 1, equation 2. So we only have 2 equations to work with. Now remember, if you're given more than 2 equations, you may have to use the 3 equations. All right, because at this level, you're not really looking for the equations. The equations are provided to you. Okay, whatever you're working with. So use the equations that are given to you and see how you can manipulate them. So now for the answer and the manipulation. Okay, because the manipulation would mean you have to see if everything is in the right order. So for example, let's look at carbon monoxide. So carbon monoxide is in equation 1 and it is on the left hand side. So carbon monoxide on reactant and 1 mole in equation 1, and so which means that we leave it as is. Okay, so leave equation 1 as is. Don't change anything about that. Now let's look for nitrogen monoxide. Nitrogen monoxide is our other reactant, but here nitrogen monoxide is in equation 2. Okay, so nitrogen monoxide is in equation 2, but on product side and 2 moles. Okay, so you can't have 2 moles of that. So which means that we need to reverse the equation so that we get it on the reactant side, because nitrogen monoxide is on the reactant side. So reverse to get NO on reactant side and divide by 2, okay, to make 1 mole. Okay, those are our 2 strategies that we need for the 2 equations that are given to us. So now we'll write the equation. So carbon monoxide gas plus half O2 gas to give us carbon dioxide gas. Delta H here remains the same. Okay, nothing is happening to the delta H because we didn't do anything to the equation. All right, now the second equation on the other side, okay, for this one, this is A, this is B. So for this was A, and for B, now we need to reverse, okay, this equation, and we need to divide by 2. Okay, so reverse and divide by 2. That's what we need to do for equation 2. So NO gas, not 2NO, NO gas to give us half nitrogen gas plus half oxygen gas. Okay, so now let's look at delta H. Delta H will be reversed, which means it is now minus 180.6, and we need to divide that by 2, okay, in order to do our mole ratio correctly. Okay, divide by 2, so we divide everything by 2 over here. Okay, so that's it. Okay, and so now what you do is you add up both the equations. Now remember, if you did everything correctly, only what you need should remain. Everything else should cross out. So look for what you need first. So carbon monoxide, nitrogen monoxide is what you need. Carbon dioxide is what you need, okay, as part of the product, and half of the nitrogen, okay, is what you need. So then you see what is remaining. Okay, and what is remaining here is half oxygen on the left hand side and half oxygen on the right hand side. So subtract half of the oxygen from both sides. So you always subtract the lower number. So in case there was 1 oxygen, by the way, 1 mole of oxygen on the left hand side, then you will still have half a mole of oxygen remaining on the left. Okay, so remember that, always subtract the lower number, so in case you have any leftovers. Okay, and you can have leftovers because that depends on what your equation is, but in this case there are no leftovers. Okay, so carbon monoxide gas plus nitrogen monoxide gas, carbon dioxide gas plus half of nitrogen gas. Okay, and then while you do the computation over here for minus 283 plus the minus of the half of the 180, you should get minus 373.3 kilojoules. That should be the answer. These are great multiple choice questions, but you still got to solve them, right? So anyhow, that's how you would do it.